Hey guys, welcome back to another video as we go along this course. I just wanted to do a little bit of housekeeping before we continue with the course content. If you go to the homepage for the uh, for the Python programming course and you scroll down a little bit past the support channels on the course section, down here they have this lectures section, and this has the list of videos that the university has uploaded with lectures that go hand in hand with the course that they have produced. And I've gone through a couple of them already. The material is really, really good. Obviously, it's university level, so it's going to be really, really thorough. But they have sort of custom course slide decks that they present, that the instructors present, the professors present, and they're really, really good. And also, they cover a little bit of some of the other stuff that I've been talking about, sort of like as a side note to some of the content that we read through. But it's really, really good. I think if you have the time to sit through it and watch the lectures, I'll just open one up here for as an example. Pardon me. Uh, yeah, you can see that they have this entire Google Docs sheet with the course material covering what the course is, and then they go through the material here. You learn about the basics. They talk about, they do some of the more elementary stuff like what is programming, why do we program, and things of that nature. So I try to cover some of the content that we go through here that isn't talked about in this course itself, but these lectures also go in depth with some of these details. Another thing is, in the last video, I did talk about self-documenting code as well as the different conventions that are used in programming when it comes to uh, naming variables, but I had forgotten to put links in the description. So I went back and I put a link to a video talking about self-documenting code by Kia Sigma Delta. I think it's a really good video. And there's also a link to this MDN article, or not an article, but entry talking about camel case convention, which I covered in the lecture video the other day. So, how we name certain variables using camel casing. But they also have links down here for snake case, kebab case, and a few other ones. So I'm sure if you click through these links, you learn more, such as Pascal case, kebab case, a snake case, etc., etc. So yeah, I think it's a good read. I think you should, if you have the time, just go through it. It's a very short read, but it's one of those things in programming that I think is important to talk about and learn as you're progressing. But anyway, with that out of the way, we can continue. If I scroll up here, you'll see that we're going to be covering, this section is going to be talking a little bit more about variables. So the learning objectives include being able to use variables in different contexts, knowing what kind of data can be stored in variables, and understanding the difference between strings, integers, and floating point numbers. Also, as you go along with this course, you'll see that there's quizzes littered throughout the entire course. They just ask for a couple of questions. You can participate them if you want. I think it's really useful for the university that keeps updating and creating this free college level courses for people to take. I think it's really good research for them to gather the data so they can be able to improve the material or edit it to a way that more and more people can be able to take on the journey. So participate if you want. If you don't, you can just skip them. I answer them when I can. And so yeah. But anyway, let's continue. So variables are needed for various purposes in programming. You can use variables to store any information that will be needed later in the program's execution. In Python, programming variables are created like so. So as you can see in these notes, they're using snake case, where the variable name, if it's more than one word, is separated by this underscore. So we can make clear distinction between the two words being used to create that variable name. Here, the ellipses or dot 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 means the value stored in the variable. For example, when you use the input command to read a string from the user, you store the string in a variable and then use the variable later in your program. like this. So we have the variable name equals input, and we take in what the user provides as that input, and we store that value into the name variable. Now, again, one thing I should mention that this is a thing again uh, when you're taking lectures or programming courses, college level ones. The material will also cover about referencing variables by value versus by a call by value versus a call by reference. It's a little bit of uh, more of a tangent, but it relates to working with variables in programming. I might make a separate video on that if people are curious, and I will also leave some links in the description if you want to learn more about it without me making a separate video. So this is what the program that we wrote here is going to print. What is your name? We give the name Ghosty, and then it reads back, hi Ghosty. The value stored in a variable can also be defined using other variables. Given name, Paul. Family name, Python. Name equals given name underscore, given name, and then we concatenate a space, and then we concatenate the family name variable here. And then when we print name, it prints the string that is produced through this. So it's going to print out Paul Python. Here, the values stored in the three variables are not obtained from user input. They remain the same every time the program is executed. This is called hard coding data into the program. So yeah, so when you manually write in what a variable is referencing or what it stores, that value, that's called hard coding. So here, given name equals Paul, we've manually written Paul, the string Paul. So this will always point to Paul unless we decide to use this variable name somewhere down the line and put another name like Jim. All right, changing the value of a variable. As implied by the name variable, the value stored in a variable can change. In the previous section, we noticed that the new value replaces the old one. During the execution of the following program, the variable word will have three different values. And this is where I was just talking about when we overwrite what is currently being stored. So here we have word equals the input that we get, that the user provides. So we can say, please type in a word, and then we're going to read back that word. And then we're going to reuse that variable named word and provide another value and do it again. But here we're just hard coding what the third value of this variable is going to be. So here when the program is being ran, we'll see please type in a word, we write it in first, and then it reads back first. Then we ask it again, we ask the user and another word, second, and we read back second, but it's this word second is being stored in the same variable named word. And then here's when we just hard coded it over here. The value stored in the variable changes each time the variable is assigned a new value. The new value of a variable can be derived from its old value. In the following example, the variable word is first assigned a value based on user input. Then it is assigned a new value, which is the old value with 3 exclamation marks added to the end. So here we have word equals, and then we assign the value from the user input. Then we read that back using the print command. And then we concatenate these 3 exclamation points and then read that back. So when the program is ran, it will be please type in a word. We enter the word test. Then it reads back test. And then we update what the variable is storing, where the string is, by concatenating these 3 exclamation points. And then we read it back. So now it's going to be test with 3 exclamation points. Here's a little side note that talking about choosing good variable names. It is often useful to name variables according to what they are used for. For example, if the variable contains a word, the name word is a better choice than, say, a. There is no set limit to the length of a variable name in Python, but there are some other limitations. A variable name should begin with a letter, and it can only contain letters, numbers, and underscores. Lowercase and uppercase letters are different characters. The variables name, and name with a capital first letter, and name in all capital are all different variables. While this rule has a few exceptions, we will ignore those for now. It is common programming practice in Python to use only lowercase characters in variable names. If the variable name consists of multiple words, use an underscore between the words. While this rule also has a few exceptions, we will ignore those for now. So here they're just highlighting that it's, again, I'm not an expert on Python. I have worked with it, but I'm not to the extent where I can call myself an expert. But here they're highlighting that it's probably conventional to use snake case when you're writing variable names. So instead of doing something like this, variable name, like how we've done for a few of our exercises so far, they prefer if you do variable name like that with an underscore separating the two words in the variable name. But if your variable name is just one word like this, then it's just all lowercase. So that's what we'll continue to do moving forward, just to keep up with the convention that they recommend for this course. But if you've ever worked with different languages, particularly JavaScript, you will notice that in JavaScript, camel case is more popular compared to snake case or Pascal case or any other convention. So some of these conventions are very language specific, and some conventions are language agnostic. All right, integers. Thus far, we have only stored strings in variables, but there are also many other types of information we want to store and access later. Let's have a look at integers first. Integers are numbers that do not have a decimal or fraction apart, such as -15, 0, and 1. The following program creates the variable age, which contains an integer value. Age equals 24. When we print age, it's going to read back 24. So this is what the program will print, 24. Notice the lack of quotation marks here. In fact, if we were to add quotation marks around the number, this will mean our variable would no longer be an integer, but a string instead. A string can contain numbers, but it is processed differently. So why does it matter that variables have a type when the following program still prints out the same thing twice? So here we have number 1 equals 100 as a number, and number 2 equals the string 100. So if we print number 1 and print number 2, we're going to be seeing 100, 100. Variable types matter because different operations affect different types of variables in different ways. Let's have a look at an example. So again, we have number 1 is set to the integer 100, and number 2 is set to the string 100. And if we do print number 1 plus number 1, this should print out 200. But if we print number 2 plus number 2, as we've worked with strings before, we know that this will concatenate instead of actually perform arithmetic operations. So this will basically extend the string to read 100, 100, and we can see it printed out down here. The first print line actually performs the arithmetic operation because Python sees that these are two integers. So we're adding 100 to 100, and it prints out 200. And over here, it sees that these are two strings, so it does concatenation. So now it becomes 100, 100, printed as a string like that. For integer values, the plus operator means addition, but for string values, it means concatenation or stringing together. Now all operators are available for all types of variables. While numbers can be divided using the division operator, attempting to divide a string by a number causes an error. So here we have a variable called number set it equal to the string 100. Then if we print number divided by 2, we get this error, type error, unsupported operand types for a string and an integer. Combining values when printing. Similarly, the following program will not work because the result is and result are of two different types. So we have a variable here called result, which equals to 10 times 25, which should be 250. And then when we print the result is plus result, we're going to get an error. It says type error, unsupported operand types for string and integer. So it won't let us concatenate a integer to a string. Here Python tells us that combining two different types of values will not work just like that. In this case, the result is of type string, while the value stored in result is of type integer. If we do want to print out a string and an integer in a single command, the integer can be cast as a string with a string function, and the two strings can be combined normally. For example, this would work. So So result is equal to 10 times 25. Then we say print the result is, and then we concatenate the result to this string by wrapping the integer result in the string function, which will convert that integer into a string or whatever value result points to. So it could be an integer, it could be whatever else, but we want it to be processed as a string, so we wrap it in this string function. So this will print the result as 250. The print command also has built-in functionalities that support combining different types of values. The simplest way is to add a comma between the values. All the values will be printed out regardless of their type. So again, this is another shorthand trick. So if you don't want to use the string function to cast the variable or the value stored in the result variable, for example, you can just do this. You can call print, write in the string, put a comma, and the right result, and Python will take care of everything. So it will print out the result is 250 as one string. And we don't have to add a space because Python, again, does that for us. And it mentions that here. It says, notice that there's an automatically added white space character between the values separated by a comma here. This is also, if you've worked with JavaScript, you'll know that if you use the console log function, that you can also do something very similar to what this is talking about. Printing with F strings. What if we want to have more flexibility and control over what we print out? So-called F strings are another way of formatting printouts in Python. The syntax can initially look a bit confusing, but in the end, F strings are often the simplest way of formatting text. With F strings, the previous example would look like this. Result is equal to 10 times 25. Then we say print. We put in this little f before the string that we want to print out, and we say the result is, then we wrap result in these curly braces, and it will print the result is 250. So let's break this apart. In the very beginning of the string we are printing out, there is the character f, lowercase f, mind you. This tells Python that we want what follows is an F string, which I'm assuming F stands for formatted or format string, but hopefully they mentioned that. Within the string enclosed in curly braces, in curly brackets, is the variable name result. The value it contains becomes a part of the printed string. The printout is exactly the same as in the previous examples. The result is 250. A single F string can contain multiple variables, for example, this code. Name Mark, age 37, city Palo Alto. Then we say print. Then we used the F string. And we say hi, name. So we can just plug in name, we can plug in age, and we can plug in city into this string. And it's gonna, and Python will take care of everything and plug in those values into where these braces are, or these brackets are. So this will print out, hi Mark, you are 37 years old, you live in Palo Alto. It is difficult to create a printout exactly like this using the comma notation in the print command. For example, this program. Name Mark, age 37, city Palo Alto, and if we just use print normally, we'll have to say hi, comma, name, comma, then we throw in this quotation marks and do this little segment, comma, UR. So you can see it kind of gets a little messy. You can also most likely forget commas, you can forget quotation marks, so you can end up having a lot of errors trying to debug this. Plus, it's also just a little bit messier to read. So if you're following along with the whole self-documenting code convention, using F-string in an instance like this might be a little bit easier on the eyes and a little bit easier to follow. So this still prints out, hi Mark, you are 37 years old, you live in Palo Alto, but you can see the errors here. Well, not errors, but sort of like the spacing issues. So there's a space before the period. We have two weird spaces here when the comma should be tucked up right next to the K, etc., etc. Notice the automatically inserted white space between each comma, separated part of the printout. Preventing print from adding the extra spaces is technically possible, but not worth the trouble given that we can instead use F strings. In its simplicity, the comma notation of the print command can often be useful, but it does sometimes cause more trouble than it's worth. F strings are usually a more reliable option. In part 4, you will learn more about the handy features of F string when it comes to formatting printouts. So here it says F strings and Python versions. If you're using an older version of Python, F strings may not work. They were introduced in Python version 3.6. Later on during the course, you will install Python on your own computer. Unfortunately, the more modern versions of Python are not always available for older operating systems. If that is the case with your computer, when there are exercises requiring the use of F strings, you can always try them out in the browser, exercise templates in these early parts of this course. So basically, if you can't install the latest version of Python on your machine, just come back to our exercise uh, editor here, the embedded editor, and just write out your code here and run it and see if that works before submitting the exercises. All right, so we have our first exercise called Extra Space, and we're told that your friend is working on an app for job seekers. She sends you this bit of code. So we have a bunch of variables here and a bunch of print statements down after. So we have a name, Tim Tester, age 20, skill 1, Python, level 1, beginner, skill 2, Java, level 2, veteran, skill 3, programming, level 3, blah, 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 blah. And we're printing that stuff out. And it says that the program should print out exactly the following. My name is Tim Tester. I am 20 years old. My skills are Python, beginner, Java, veteran, programming, semi-professional. I am looking for a job with a salary of 2,000 to 3,000 euros per month. The code works almost correctly, but not quite. This exercise has very strict tests which check the output for every single bit of white space. Please fix the code so that the printout looks right. Notice especially how the comma notation in the print command automatically inserts a space around the different comma separated parts. The easiest way to transform the code so that it meets requirements is to use F strings. Hint, you can print an empty line by adding an empty print command or by adding the new line character into your string. Do remember to be extra careful when formatting printouts. Also, in the future on this course, some of the exercises have tests that require your output to be exactly as specified in the examples given. For example, please use actual whitespace characters in your code instead of ASCII characters for whitespace or some such. Okay. So let's run this first and see what it says. My name is Tim Tester. I'm 20 years old. So we can see here first, this needs to be fixed. The spacing here needs to be fixed. So we'll just, and here everything looks normal. No, so this needs to be fixed. So yeah, probably just have to use F strings throughout to make this easier for ourselves. So here, F. So we say, my name is, instead of ending our quotes here, we just wrap name like that. And then we should do I am like that. Age years old. So when we run it, there we go. My name is Tim Tester. I am 20 years old. Then we need to put an empty space here. So we have two ways we can do that. The first way is just having an empty print. So when we run this, we have a new space here. Or you can, at the very end here, just do /n. So when I close that, it does the same thing. So we'll leave this for now. Actually, we'll do it this way, and then we will run it, see if we pass all the tests, and then we'll come in here and clean it up a little bit. So we can use a little bit less code to do the same thing. Okay, so my skills are, does this look exactly? Yep. So again, same issue. So we want a space before, but not after. And then here we put level, instead of a comma, we do that. And we surround this in quote and parentheses. If we run, we have an error here because we're missing a closing parentheses. There we go. So Python beginner, and so we just replicate this over here. Like that. And then if we, we gotta also wrap this in curly brackets. Okay. Looking pretty similar. And then we do the same thing here. Like that. And if we run our our code, should look like that. And then here at the very end, it says I'm looking for a job with a salary of lower. Get rid of that. Opening curly brace, closing curly brace, space, euros per month. And I think we should be okay here. Let me just look. Okay, no weird spaces. Actually, we do need an empty print here to bump this down a little bit. So if we run, my name is Tim Tester. I'm 20 years old. My skills are Python beginner, Java veteran, programming semi-professional. I'm looking for a job with a salary of 2,000 to 3,000 euros per month. Let's run our test, see if we pass. And we do. We can also view the model solution. But before we do that, I'm just going to go in here and do that so that we can remove this and remove this and do the same thing here. In fact, like that. So if we run it, it still looks the same. And if we test, we should be cool. And we do pass the test again. So we can take a look at the model solution. And they did it this way, added an empty print statement here and one more here like we did. But everything else should be formatted the exact same way that we did. Now you can see here they did it this way, right? They didn't use print the F strings. Down here they did use the comma separated printing version using the just standard print command from Python. But we just went ahead and did all printf because why not? It just makes things a lot easier and a lot cleaner for us. Easier to read, easier to format. But yeah, so this is it. My solution to this exercise. You can do it this way, combination of both, comma separated and using F strings, or you can just go all out on F strings and just make it easy for yourselves. Awesome. All right, floating point numbers. Floating point number or float is a term you will come across often in programming. It refers to numbers with a decimal point that can be used much in the same way as integer values. This program calculates the mean of three floating point numbers. Number 1 is equal to 2.5, number 2 is equal to negative 1.25, number 3 is equal to 3.62. Then the variable mean is assigned the operation of adding all three numbers, dividing them by the number of numbers that we have, and that gives us our mean. This is just math, high school math, I think, and maybe even middle school math. So the mean is 1.6233333. Here we have another exercise called arithmetics, and we are instructed. This program already contains two integer variables, x and y. X is equal to 27, y is equal to 15. It says please complete the program so that it prints out the following. 27 plus 15 is equal to 42, 27 minus 15 is equal to 12, 27 times 15 is equal to 405, and 27 divided by 15 is equal to 1.8. The program should work correctly even if the values of the variables are changed. That is, if the first two lines are replaced with 4 and 9 instead of, 27 and 15. So the program should print out 13 minus 5, 36, and 0.444. Okay, so we should just do print. And we want to do, I'm curious, 4 plus 9 is equal to, if this will work, x plus y. Let me run this and see what we get. Aha, so it does work. Okay, then we need to do minus, so we print f4 minus, oh, actually, no, that's not right. It should be y and x. Right? Right, so because if we change this to 4 and 9, or whatever the case, it should still print them out. Yeah, okay. So we'll duplicate that. Now we need to do subtraction. Now we do x minus y. Whoops. Then we need to do multiplication. Whoops, sorry. And we need to do division. So 42, 12, 405, 1.8. And yeah, we get the same thing here. So if we run the test, we should be kosher. And we are. I'll open that for now, but we won't check it. So sometimes it's, again, one of the things I like to do, just go back and see if we can do it any other way. So if we do it with a regular print, I think we can do print, and we can say print x comma plus comma y comma and then x plus y. Well, actually no, it should be equals, right? Plus equals, comma equals comma x plus y. Let's run this and see what we get. So yeah, that works. So I'll do this for now. Comment that out, and you can comment out a line on the embedded editor by holding Control and then the /. It will turn whatever line that your cursor is currently hovered over or is currently selecting, and it will turn that into a commented out line. So the editor won't execute this code when we comment it out. That's why I did it over here, so we can kind of do this as a separate solution. If you want to do it using just regular print instead of using printf. So here we need to do the subtraction, so we can do x comma minus as a string comma y comma equals as that comma, and we do x minus y. Again, if we run it, there we go. And then we can do the multiplication, and we can also do the division. Like that, and it should still work the same exact way. So if we submit, do the test, see what we get. Okay, we still passed. Take a look, and here you can see. So again, this is like, so first solution was this using printf, which it's what they did over here, and also another solution would be just using the regular, you can do f strings or just regular print without f strings, which is what we did. So these are two solutions that you can use for your exercise. You can just use regular print using comma separated values. Python will automatically execute the arithmetic operation here without us having to do anything extra, because Python sees that these are two floats. And again, floats can be whole numbers or decimals. So Python knows that for us. Or you can also use f strings. All right, awesome. I think this is the last exercise. It is. Looks pretty extensive. And so it says fix the code, print a single line. So we're instructed each print command usually prints out a line of its own, complete with a change of line at the end. However, if the print command is given an additional argument and equals empty string, it will not print a line change. For example, print hi, comma, and equals, and then print there, and it'll do hi there. Oh, that's clever. Please fix this program so that the entire calculation, complete with result, is printed out on a single line. Do not change the number of print commands used. Okay, so let's run this and see what it does. So here it just does 5 plus 8 minus 4 equals 9. So if we do equals end equals, what happens? So now it moves the plus up. Same thing, if we do comma, end equals an empty string, it moves the 8 up. So we just have to do that for every one of them, except the last one, I think. Do run, now we have 5 plus 8 minus 4 is equal to 9. And I think that should be the answer. So if we test, It is awesome. If you view the model solution, again, always easy, always a good thing to compare your notes. And yeah, we did the same thing. Just added end equals empty string here to the end of each, well, adding it to as a second value to the print command, and that's it. Now I should note that I did end equals with no spaces here, but they did it with a space, so I don't think that makes a difference. I think this is kind of easier to read as we're right. So they did put a space here, but we didn't. So I guess that is the way to do it. Um, like this, perhaps for legibility, but it hasn't made a difference for our code. It still works. And if we test, we pass all our tests. So I think that's going to be it. This was a chapter where we started learning about working further with variables. We did some exercises, we did some readings. Again, I try to keep the videos around 30 minutes at most because I want them to be quick and digestible and easy to follow along. You can just sit down, do it 30 minutes if you have 30 minutes, and follow along, submit your exercises, and you can move on to do something else with your time and then come back another time, spend another 30 minutes, and so on and so forth. So as you can see, the further we go along, the more the exercises, the readings and the exercises become a little bit more extensive, but that's the fun in programming. The further along you go, the more you learn, yada, yada, yada. So I'll see you guys in the next video. Again, thank you so much for watching.